Welcome to a new exercise. Last time I promised you that we will start throwing things from buildings, so let's get it started. A person drops a ball from the edge of a building 45 meters tall. Find the time for the ball to reach the ground. How fast will it be moving? Two questions. We need to find time and we need to find final velocity. The only information we have is how tall this building is. So step one, cartoon and choice of coordinates. We start with our y-axis. Down here we have the ground corresponding to y equal 0. And here we have the edge of our building. And somebody's here on top of the building, and this person will drop this ball. One important comment about the word drops here. The word drop, contrary to the word throwing, refers to the idea of just releasing the ball. That means that the person will have the ball on top of this building and it will not give it any initial velocity. In other words, Vy0 is 0. There is no initial velocity. The person will just release the ball, which will hit the ground sometime later. In fact, that's one of the questions we need to answer. Alright, so this is the idea of dropping a ball. We know how tall this building is. This corresponds to the point H. This is 45 meters. And we need to find the time that it takes to hit the ground. Since time is involved, we go to our equation that tells us about the location of the ball in the y-axis. So the height is the initial height plus the initial velocity in the y direction times t minus 1/2 g t squared. The initial height is precisely the height of the building, so let's call this h, plus the initial velocity. We know this term is 0 because the ball was dropped, was not thrown. So this is 0 minus 1/2 gt squared. This expression is valid at any point on the y-axis, but we're interested in what happens down here. So when we want the ball to hit the ground, because that is the time that we need to find. We're being asked about the time that it takes to the ball to reach the ground. In other words, we want y to be 0. So we set 0 equal to h minus gt squared. And here we solve for this equation for t. So minus. We solve this equation for t. So we take this term over the other side. We get 1/2 gt squared equal to h. And now we multiply everything by 2 to cancel this factor 1/2 and divide by g. So we get rid of this. We get t squared is 2h divided by g. And now we take the square root, so we get rid of this t squared. T becomes square root of 2h divided by g. And this is also a very general expression, so I usually keep it with me on my list of formulas because I have not plugged any number here. So this is the time that it takes for any object that is dropped from any height h under the action of gravity. We can now plug our numbers. We get the square root of 2 times 45 meters divided by g, which is 9.8 meters per second square. We plug these numbers in the calculator. The square root of 2 times 45 divided by 9.8. Make sure that everything is under the square root. And this is 3.03, so basically 3 seconds. 3 seconds. This is the time that it takes for an object, the ball in this case, to hit the ground when it's dropped, that means it's released, of an altitude of 45 meters. The second part, we're asked to find the speed. So how fast will this ball moving when it hits the ground? Since we have the time, we can simply use the formula that relates final velocity and time. So final velocity is initial velocity, put the y's everywhere, minus g times t. The initial velocity was 0. We knew this guy was 0 because the ball was dropped. Minus g, which is 9.8 meters per second square, times the time, which is what just found on the first part, 3 seconds. Let's see what we get. Minus 9.8 times 3, 29.4. We can simply write minus 29 meters per second. So this is the velocity when the ball hits the ground. Notice the minus sign here in front of the 29. This is telling us that the velocity is pointing downward, which is exactly what we expect since the ball is going all the way from the top of the building, hitting the ground. So the velocity here at the bottom is pointing downward, which is in the opposite direction from the y-axis. This is why we find this negative sign. In the next exercise, we're going to make things a little bit more interesting because instead of simply dropping objects, we're going to start throwing them from the top of buildings. So don't miss that.